For thousands of years, humans looked at the sky with wonder. They saw the sun rise in the east and disappear in the west, and they felt the ground beneath their feet as flat and endless. To early humans, it made sense to believe the earth was flat. After all, when you stand in an open field, everything looks level. No curves. No edges. But curiosity is the beginning of science. More than 2,000 years ago, ancient Greek thinkers started asking a simple question: what if the earth is not flat? They noticed something strange. When ships sailed away from the shore, they didn't simply become smaller and vanish. Instead, the bottom of the ship disappeared first, and the mast vanished last. If the earth were flat, the ship would disappear all at once. This slow, layered disappearance hinted at a curved surface. One man, Aristotle, observed another powerful clue. During lunar eclipses, when the earth passes between the sun and the moon, the shadow cast on the moon was always round. No matter the angle, the shadow remained circular. Aristotle reasoned that only a spherical object can always cast a round shadow. This was a strong sign that the earth is round. But the most brilliant proof came from a man named Eratosthenes. Around 240 BCE, Eratosthenes knew that in a city called Syene, modern-day Aswan, Egypt, the sun stood directly overhead at noon on the summer solstice. At that exact moment, vertical sticks cast no shadow. However, in another city, Alexandria, the same sun cast a noticeable shadow at the same time. Instead of ignoring this, Eratosthenes measured the angle of the shadow. Using simple geometry and the distance between the two cities, he calculated the circumference of the earth. Amazingly, his calculation was extremely close to what modern science confirms today, all without satellites, airplanes, or space travel. As centuries passed, more evidence appeared. Travelers noticed that different stars were visible in different parts of the world. When moving north or south, some stars disappeared while new ones appeared. This would not happen on a flat Earth. The sky itself was changing because people were moving across a curved surface. Then came the age of exploration. Sailors like Ferdinand Magellan set out on long voyages. His crew eventually returned to their starting point after traveling in one direction around the world. They had circled the Earth. This journey proved, in practice, what scientists already knew: the Earth had no edge. Later, Isaac Newton explained why the Earth is round. Newton discovered gravity, the force that pulls matter together. When a planet forms, gravity pulls material evenly toward the center from all directions. Over time, this process naturally creates a sphere, because a sphere is the most stable shape under gravity. The Earth isn't a perfect sphere, though. It slightly bulges at the equator and flattens at the poles due to its rotation. This shape is called an oblate spheroid, but to the human eye, it appears perfectly round. In the 20th century, the final doubts disappeared. Humans sent satellites into space. Astronauts traveled beyond Earth's atmosphere. And for the first time in history, people saw photographs of Earth from space, a beautiful blue sphere floating in darkness. There was no edge. No end. Just a round planet, exactly as science had predicted for centuries. Today, GPS systems, satellite communication, time zones, and space missions all rely on one undeniable fact: the Earth is round. If it were flat, none of this technology would work. So the idea of a round Earth is not a belief. It is not an opinion. It is a conclusion built on observation, mathematics, physics, exploration, and direct visual proof. The story of why the Earth is round teaches us something bigger than science. It shows that asking why can change the way humanity understands reality. And sometimes, the truth has been right in front of us, slowly disappearing over the horizon.